So just a quick note on the alignment procedure for this one. So the first thing we want to do is we want to make sure that there's no significant DC offset on the output, right? So there's a DC offset pot right, focus, there you go, right there, right? And we can turn that, and you can see that right now we have quite a bit of DC offset. We have like 0.1 volts almost. So you can turn this either direction, and you're going to see that there's a little lag when you turn it, and that's because there's a capacitance that we're charging here. So if we turn this, I think that was the wrong way. Turn this a little bit more this way. Okay. Here we go. All right, so we're starting to be fairly low here. We're starting to be, there we go. That's about 27, 26 millivolts on the output. I'm fine with that. I guess we could even turn it a little bit more here. As you can see, it's kind of annoying to adjust it because you have this lag. This is about as low as we're gonna get it. So yeah, that's less than 10 millivolts. That is absolutely perfect. So we can move on to the next step. The next step is going to be to set the bias current, right? So to do that, we measure across the source resistor, which is this one here. And the source resistor, so we have, what do we have? About 20 millivolts right there. So our source resistor is about half an ohm. So that means that 20 millivolts is equal to 40 milliamps, which is kind of okay, right? But we can turn this up and down here, as you can see. I can turn it down, or I can turn it up, but let's set that to about 20 millivolts, which is, again, 40 milliamps of bias current. That should be fine. So, and you can see that it's stable. It's not running away or anything like that from us. That's fine. You probably should put the bias transistor on the heatsink. I haven't done that right now. It's just sitting right there. But you probably should do that. But what we can do now is we try to run some signal through it. So if we look here, I have 100 millivolts here, and I'm going to turn on right now. 100 millivolts of signal times 40 times gain is 4 volts. And guess what? We are at 4 volts peak right there. So that's great. Perfect. We are good in that regard. Now, we can, of course, increase that a little bit and just make sure that nothing blows up. So if I, go up to 300 millivolts, that gives us about 9 volts peak, and yeah, that's good. That's great. So we've set the DC offset, and we set the bias current. It all looks good. If I turn this off, you see that this actually settles down to 25 millivolts, which is what we have. So it's actually thermally stable without me having to put that bias transistor on the heatsink. Whether you want to do that is up to you. You probably should. I have found that at least with the IRF P240s, I can get away without putting that on the heatsink. But you probably should. Better safe than sorry. So I hope this was helpful. Thanks.